Welcome to Module 1 of this course on Big Data Architectures. In this module, you will provide an overview of Big Data Architecture and discuss the different types of Big Data Architectures. In this topic, we will introduce you the fundamentals of Big Data Architecture. You will learn about the various components that make up a big data architecture, like data source, storage, processing, and visualization. By the end of this topic, you will have a solid understanding of what a big data architecture is and how it works. A typical big data architecture is comprised of multiple layers that work together to process and store and analyze large amounts of data. The layers of big data architecture can vary depending on the specific needs of a big data organization project. But generally, it includes data source layer. This layer includes all sources of data, like social media, mobile devices, and sensors. The data is often collected in a raw form and require pre-processing before it can be used. Data ingestion layer. This layer is responsible for collecting, validating, and processing the data from the data source layer. It includes tools such as ETL, it means extract, transform, load, that enable the data to be transformed and prepared for storage. The data storage layer. This layer stores the data, the processed data, and the ingested data. It includes various types of data storage systems like Hadoop distributed file system, HDFS, NoSQL databases, and cloud storage systems. The data storage layer can also include data archiving systems for long-term data retention. Batch processing layer. This layer is responsible for processing large amounts of data in batch mode. Real-time processing layer is a layer that process data in real time or near real time. This layer, analytics and visualization, is responsible of visualizing and representing data in meaningful way. Data workflow management and scheduling layer is responsible for managing and scheduling the processing of a data workflow. There is also data query layer, which is similar to data processing layer, and it provides tools for querying and retrieving data from data storage layer using like SQL query scripts. Now let's discuss the different types of big data architecture, including the three popular Kappa, Lambda, and Microservices Architecture. You will learn about the difference between this architecture and the advantage and disadvantage of each one. Let's start with Lambda Architecture. Lambda Architecture is designed to handle large volumes of data in real time. It consists of three layers: a batch layer for processing data, historical data, and a speed layer for processing real-time data, and the third one, the serving layer, for querying results. The batch layer stores all the data and processes it in batches. The speed layer processes real-time data and sends it to the serving layer for analysis. The serving layer is responsible for querying data and returning the results. Next, let's talk about Kappa architecture. Kappa architecture is an alternative of the popular Lambda architecture. It is designed to simplify the architecture by using only a single processing layer. It uses stream processing to handle both real-time and historical data. Kappa architecture is particularly useful when dealing with real-time data that needs to be processed quickly. Finally, let's discuss microservices architecture. Architecture is a software architecture pattern in which complex applications are broken down into smaller, independent services. Each, each service is responsible for a specific function and they communicate with each other through APIs. Microservice architecture is practically useful when dealing with large, complex applications that need to be scalable, maintainable, and testable. In big data context, microservices can be used to break down complex big data processing tasks into smaller, independent services that can be managed and scaled independently. This can improve the overall scalability, maintainability, and flexibility of big data applications. For example, a big data application could consist of microservices for data ingestion, data processing, data storage, and data visualization, each with its own independent scaling and management strategy. Now, let's compare these three architectures in terms of adoption, implementation, performance, resource usage, and maintenance. Let's start with adoption. Lambda architecture is widely adopted and has been around for over a decade. It is well established architecture and it's supported by a wide range of tools and platforms. Kappa architecture, on the other hand, is a relatively new and has not been adopted as widely as Lambda architecture. Architecture is also widely adopted, but it's more commonly used for general software development rather than specifically for big data applications. Next, let's talk about implementation. Lambda architecture is a complex and require the implementation of three different layers. You remember, it's batch, speed, and service layer. This can make implementation challenging and time consuming. Otherwise, Kappa architecture, on the other hand, is simpler as it only requires a single processing layer. Microservices architecture is also relatively simple to implement as it involves breaking down a complex application into smaller, independent services. When it comes to performance, Kappa architecture and Lambda architecture are both handle large volumes of data and process it in real time. However, Kappa architecture is designed specifically for real-time data processing and may perform better in this context. Microservices architectures are also uh, can also handle large volumes of data, but performance may be affected by the overhead of communication between services. Now, let's discuss resource usage. Lambda architecture requires more hardware resource than Kappa architecture due to the three layers structure. Kappa architecture, on the other hand, is more resource efficient and it only requires a single processing layer. Microservices architecture can also be resource efficient, as each layer can be scaled independently and only the required resource are used. Finally, let's talk about maintenance. Lambda architecture can be challenging to maintain due to its complexity and the need to maintain three different layers. Kappa architecture and microservices are both simpler to maintain, but microservices architecture can be more challenging to manage due to the need to coordinate communication between multiple services. In conclusion, Kappa, Lambda, and microservices architecture all have their strengths and weaknesses in the context of big data applications. Lambda architecture is widely adopted, but complex to maintain and to implement, while Kappa architecture is newer but simpler and more focused on real-time data processing. Microservices architecture is widely adopted for general software development, but may require more effort to manage in a big data context. By understanding the difference and trade-off between this architecture, you can make an informed decision to on which one to use in your big data application and project.